Okay, so we have the 6 meters per second, and now we can look over here and see that it's 0 and 0. So that is the final velocity. So what is the initial velocity? Over here, 0. So we can write that. And then the time final is 3 seconds. So we can write that over here. Minus the time initial, which is 0 seconds. So you write that over here. Now we can solve this and we still get 6 meters per second divided by 3 seconds. So now what is 6 divided by 3? 2 meters per second squared. This is our acceleration. And an easy way to understand this is by looking at the graph. So you know the acceleration is 2 meters per second. And so you can look here at 0. It's at 0. And then after 1 second, it's at 2. So during that 1 second, it traveled 2 meters. During that 1 second, it went from 0 meters per second to 2 meters per second. And then on second 2, it's around 4. If I knew how to draw graphs well, it's around 4 meters per second. And so from 1 to 2, 1 second passed, and it went 2 more meters per second. And this pattern keeps repeating. And that is why that's the acceleration, because essentially, acceleration is the slope of a velocity time graph. Now, if we draw some velocity time graphs without any numbers, just like this, what can we tell about these graphs? Let's imagine they're velocity time graphs. Okay, so what can we tell about these specific graphs? Well, this one, we can say that it has a positive velocity and we can say that it has an increasing velocity because, like I mentioned before, as time increases, velocity is increasing. Because as time passes, velocity is increasing. And we can say that there is acceleration because the line is curved, and because it's going upward, and the line is above the x-axis, we can say that it is positive acceleration. Now, let's go to this graph to compare. So, this graph, the line is also above the x-axis, which means it also has positive velocity. And is the velocity increasing? Well, as time passes, velocity is increasing because as time passes, velocity is so the line is does it have an increasing velocity or a decreasing velocity? Well, in this case, since the line has a slope that is gradually becoming less, it's decreasing, we can say that this graph has So, for this graph, velocity is decreasing, and we know that because the slope is decreasing. So in this graph, velocity is decreasing because the line is moving forward and the acceleration is positive. So the velocity is decreasing because as time passes, it might look like it's increasing, but then the slope becomes flatter and the velocity remains the same. So for this graph, the velocity is decreasing because the line is becoming flatter over here. Here it's rising, but then it becomes flat. So there's a decreasing velocity. What about acceleration? Well, in this case, the acceleration is negative because although velocity is positive, the velocity is decreasing, which means that it is negative acceleration. Now, a helpful diagram, sort of, to help understand when things are positive and negative, because it might be confusing, is so one diagram we can draw to help understand what things are negative, what are positive, increasing, decreasing, all of that, is this. So if we have a positive velocity, and a positive acceleration, then we have the object speeding up forward. If we have a positive velocity but a negative acceleration, then the object is slowing down backwards. Then, if we have negative velocity, and we have positive acceleration, then we have the object slowing down backwards. But if we have a negative velocity and a negative acceleration, then we have the object speeding up backwards. And actually, this is forward, not backward, my mistake. So yeah, this diagram can help you figure out things that are positive, negative, increasing, and decreasing. So we can look at this graph over here and see, is the velocity positive? Yes, so we can look at this line, we don't need to look at this one. But is the acceleration positive or is the acceleration negative? And also, we don't necessarily have to look at this column before this one. We can look at this one before this one. So, is the object speeding up forward? Well, in this case, yes. And so, that means there is positive acceleration. So we can write those three characteristics here. And increasing velocity means the car is speeding up forward, basically. And so, for this graph, is the velocity positive? Yes. So we still don't look at this one. We look at this one. And is the object slowing down forward? Well, in this case, Yes. And with forward, I mean above the x-axis. So this is the x-axis. And if it's above, then it's going forward. And so it's slowing down forward, which means there is negative acceleration. And so we can write those three characteristics over here. Now, we didn't get to use this part, so let's draw some other graphs. If we draw this graph, and then this graph, and this is time, and this is time, this is velocities, velocity, time. So now, is the velocity positive or negative? So is it above the x-axis? No. So it's negative. And is there positive acceleration? Well, if we don't necessarily know that, we can look at the other columns, this one. But if we do know that, then we can just look at that. So is there positive acceleration? So in this case, it might be easier to know if it's slowing down backwards or speeding up backwards. So backwards means that it's below the x-axis. So yes, both of those could be. But one of them says slowing down and the other one speeding up. So how do we know if one is slowing down or speeding up? Well, in this case, the velocity is becoming flatter. Basically, the slope is becoming flatter. And so this means that the object is slowing down. And so the object is slowing down backwards. And if it's negative, then positive acceleration. So this graph has a negative velocity because the line is below the x-axis, a positive acceleration, and it is slowing down backwards, which also means it is decreasing. And then for this graph, what do we know? Is the velocity negative? Yes, because it's below the x-axis. Is the object speeding up backwards? Well, velocity, the slope of the line suddenly goes very steep down. And so that means the velocity is increasing, though it's negative. And so for this case, the object is speeding up backwards, and that means there's negative acceleration. So for this graph, the velocity is also negative. There is a negative acceleration, and the object is speeding up backwards. And so basically, this is what you can tell from this velocity time graph. And also, there is another type of graph called an acceleration time graph. Although the position time graph and velocity time graphs are probably more important. So basically, an acceleration time graph is just like the others. It has time in seconds, for example, and then acceleration in meters per second squared. And this is 0. And then what do you write? Well, imagine acceleration is constant, not velocity, but acceleration. So if acceleration exists, and it's, for example, 2 meters per second squared, then we can plot that over here. So we go to 2 meters per second squared, and then we draw a line like this, because the acceleration isn't changing. It's always 2 meters per second squared. And so if the acceleration was negative 3 meters per second, then the line would look like this. So unless the acceleration itself is changing, the line will always be straight. And so overall, we discussed speed, velocity, acceleration, position time graphs, velocity time graphs, and acceleration time graphs. We discussed them just a little. And we also discussed displacement and distance. And so these were basically all of the key terms that we discussed, other than increasing, positive, negative, those words. And, well, we also did slope, and, well, yeah, these are basically the topics and the keywords that we can use to describe motion. So, I think that's it. Thank you for watching. See you in the next video.